Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x squared plus 2 equals 27 to the power of x. Now what I'm first going to do is I'm actually going to replace 27 with 3 to the power of 3. Because remember, 27 is 3 to the power of 3. And we are powering this with x. So we have 3 to the power of x equals 3 to the power of x squared plus 2. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. So this is an important property of exponents. So if we have 3 to the power of 3 to the power of x, this is actually equal to 3 to the power of 3 times x, which is simply just 3x. And this is equal to 3 to the power of x squared plus 2. Now, because our bases here are the same, that means our exponents are the same as well. Because if we have a to the power of x equals a to the power of y, this means that x is actually equal to y. So that means that x squared plus 2 is equal to 3x. So now if I subtract by 3x on both sides, I get x squared minus 3x plus 2 equals 0. And now, as you can see, we have a quadratic equation, meaning we can find the solutions to this using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So a is 1 because there is no coefficient here. B is negative 3 and C is 2. So now if we plug this into the formula, we get negative b, so 3 plus or minus the square root of negative 3 squared is 9 minus 4 times 1 times C is 2. And we are dividing this by 2 times 1, which is simply 2. Now, 9 minus 4 times 2 is 8, so we have 3 plus the square root of 1, which is simply 1 over 2. And we also have 3 minus 1 over 2. Well, 3 plus 1 is 4, and 4 divided by 2 is 2, so x equals 2 is one solution, and 3 minus 1 is 2, 2 divided by 2 is 1, so x equals 1 is another solution. So now, these two are our solutions to this equation. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation with, as you can see, 2 different bases. So what our first step is going to be is we're going to expand our right-hand side here. We have 5 to the power of x plus 2. And remember, let's say we have a to the power of b plus c. An important property of exponents is that we can change this into a to the power of b times a to the power of c. Because remember, when we're multiplying exponents, we add these two. So all we're doing is we're simply reversing this. So that's what we're going to do to 5 to the power of x plus 2. We're going to reverse it back to its original form and expand it. So 5 in this case is a, right? So we have 5 to the power of b is x, times 5 again to the power of c, which is 2. And this is still equal to 2 to the power of x. Now, 5 squared, as we all know, is 25, right? So this is 5x times 25 equals 2 to the power of x. Now what we're going to do is we're going to divide both sides by 5 to the power of x. So if we divide both sides by 5 to the power of x, well, for this side, these two will cancel out. So on our right-hand side, we'll just have 25. And on our left-hand side, we'll have 2x over 5 to the power of x. And this can actually be written as 2 over 5 whole power x. And this is equal to 25. So now what we're going to do is we're going to take the log base 2/5 of both sides. So we're going to take the log base 2/5 of both sides. Well, these two actually cancel out because remember, the log is the inverse of an exponent. So because this is base 2/5, these two are going to cancel out. So on our left-hand side, we have x equals, and on our right-hand side, we have log base 2/5 25. And this is actually equal to, using the change of base formula, which is an important property of logarithms, log 25 over log 2/5. The change of base formula states that if we have a logarithm like this, log of this equal over, so this equals log of this over the log of the base. So now this can be converted to, let me write this over here, log 5 squared, because we're simply changing the 25 to a 5 squared, over log 2 minus log 5. We remember, when we're subtracting logarithms, we divide. So we're simply just inversing that. So log 2 minus log 5. And this, an important property of logarithms, the power property, states that this, we can just drop down the exponent here in front of the log. So this can equal 2 log 5 over log 2 minus log 5. And this is our answer in its simplest form. If we want a more simpler form, we need to use a calculator for that, but this is the most simplest form we can write our answer in.